This video looks at a technique called proof by induction. Now we're given a sequence in which we know the first term. Now this sequence can generate successive terms. So for example, to find A2, I do 3 times A1 plus 1. Well, A1 was 1, so 1 plus 1 is 3 times 2 equals 6. I could then find A3. I do 3 times A2 plus 1. Well, A2 was 6, so 6 plus 1. 3 times 7 is 21. Now that's all well and good, but to find A100, say, you'd have to keep on going and find A4, then A5, then A6, and it becomes quite a time-consuming technique. So instead, I want to prove that a formula exists to find any term I want in the sequence. And to do this, we use proof by induction. Now then, the first step is to check that this actually holds for the first term. Otherwise, there's no point in proving it. So if I let n equal 1, then a1 equals 5 times, well, n is 1, so 1 take 1 is 0, so 3 to the 0. Take away 3 all over 2, and then 5 times, that's 1, so 5 times 1 take away 3 is 2, 2 over 2, which equals 1. So at least that gives us the correct first term. Now to prove it's true for all terms, we follow the following precise logical steps. We assume it's true for a particular value n equal to k. So I've assumed that ak is equal to 5 times 3 to the k minus 1, take away 3 over 2. So that's the same statement as above, rather than an n, I've got a k. Then in theory, the next term along should equal 5 times 3, rather than k minus 1 there should be a k, take away 3 over a 2. And I will show that this is indeed the case. Right, if I refer back to the given question, I know that ak plus 1 is 3 bracket ak plus 1. And I've assumed that ak equals this, so I will sub that into this formula to get 3 bracket 5 times 3, k minus 1, take 3, all over 2, plus a 1. Right, I will then write the 1 as 2 over 2. So plus 2 over 2. And then I can then add together the two fractions, so I get 3 bracket 5 times 3 to the k minus 1. Well, minus 3 plus 2 is just minus 1 all over 2. And if I then times by 3, well, 3 times 3 to the power of k minus 1 is just 3 to the power of k. So I get 5 times 3 to the power of k. 3 times 1 is 3, all over 2. And I've therefore proved the required result. So, let's conclude. We've shown that if it is true for n equals k, then it must also be true for n equal k plus 1. However, because it's definitely true for n equals 1, must be true for n equals 1, 2, 3, all values of n.